In addition to arithmetic and geometric sequences, you guys are also responsible for knowing about recursive sequences. Before we talk about those, let's think about the values n, n minus 1, and n plus 1 in the context of a number line. If we put n right in the middle of this number line, we know that the value after it is just whatever n is plus 1. We know that the value before it is whatever n is, but minus 1. If you let n be maybe, I don't know, 3, 3 plus 1 is 4, 3 minus 1 is 2. This sequence should kind of make sense to you. So that means for the terms an minus 1, and an plus 1 in any sequence, follow that same order. If this is the an term, then the term before it is the an minus 1 term, and the term after it is the an plus 1 term. Again, let's let our n be 3. This term would be a 3. Of course, the term before it would be a 2, or 3 minus 1, and the term after it would be a 3 plus 1, or 4. Again, this sequence, an minus 1, then a plus 1, should make sense.
Who thinks more is better than less? Okay, why?
More is better than less, because if stuff is not if there's more less stuff, then you might want to have some more, and your parents just don't let you because there's only a little bit.
Right.
We want more. We want more. Like, you really like it. You want more.
I follow you.
It's not complicated. More is better. And AT&T has the nation's largest 4G network.
This brings us to recursive sequences. Now, the word recursive, if you've heard it before in programming or something else, just means that each thing depends on what happens before it. So a recursive sequence is one where each term depends on the term before it. Here's an example of one. A sub n equals an minus 1 plus 5. Now, I know this looks scary, but let's break it down. An is just the nth term or any generic term of this sequence. So to find any term in this sequence, we're given this rule. This rule says, take term an minus 1. If you look at your number line above, an minus 1 is just the term that comes directly before the anth term. So all you do is you look at the term that comes before it, you take that term, and you add 5. Now, if you're always telling you to go back to the term before it, and go back to the term before that, and go back to the term before that, they have to give you somewhere to start. Another big red flag that you have a recursive sequence on your hands is that they will give you the first term. They have to give you a starting value. So, for example, if you're trying to find term A4 in this recursive sequence, all you would do is take the term before it. 4 minus 1 is 3. The term before the fourth term is the third term, term A3. And then you would add 5. Let's try one. I want to write the first 6 terms of this sequence. Before we start, let's break it down. It says any term is just given by 4 times the term directly before it. Remember how an minus 1 is the term just before an. After you times that by 4, you just subtract 1. Where do we start? It tells you that the first term is a 2, so you start with a 2. Let's try to find A2. Remember that any term is just 4 times the term before it minus 1. So if we're trying to figure out term A2, we look at the number before it. That's a 2. To determine this second term, we just take 4 times that 2, which is 8, and subtract 1, which is 7. Term A3. Now, A3 depends on A2. So to figure out term A3, you take 4 times the term before it, that's 7. 4 times 7 is 28, and then subtract 1, which is 27. The next one, term A4, we just take 4 times the term before it, which is 27. 4 times 27, that's 108, and subtract 1 to give us 107. Term A5, we just take 4 times 107 and subtract 1, which is 427. And then the sixth term, we take 4 times 427 and subtract 1, and we're left with 1,707. Try the recursive sequences on the back. Again, you're going to know you have a recursive sequence because you're going to see an an-1 in the rule, and they're always going to have to give you a place to start.
Is saving money better than not saving money?
Yeah!
Okay, if you save enough money, what would you do with it?
I would buy an island made out of candy.
An island made out of candy.
It would be like sand full of sugar.
Sand full of sugar?
The water can be made out of like soda. When you take a shower, it can be made out of like hot fudge.
Ooh.
What about the animals? What would they be made out of?
I'm assuming they'd be made out of candy.
It's not complicated. Saving is better. Switch to AT&T, and your family can save up to $100 a month with Mobile Share.